Hi, welcome to the video lecture series on computer architecture, and today's video lecture we are going to learn about the important topic called as addressing modes, and this is Dr. K. Sivabalan, professor in IT department, Sri Krishna College of Engineering and Technology. So, we will proceed with addressing modes. So, the first addressing mode is meant by addressing mode. In general, an addressing mode is actually the way of taking the data. Data in the other sense, other data can be called as operand. So, as far as assembly language is concerned, we will be taking the data from memory or a processor register. If you are trying to take that from a memory or processor register, then such kind of mechanism is called as addressing mode. Now, the first addressing mode what you are going to learn is called as immediate addressing mode. So, in this case, an instruction will be there and the operand will be the part of the instruction. So, I have given you an example here, MOV A specifies the accumulator here, and 05H is called as an operand. Okay. In this case, 5 is called as an operand, H actually means for hexadecimal. So, when I try to execute this instruction, what will happen is value called as operand 5 will be getting stored in the accumulator called as A. Now, when you see here, what happens is the value 5 is getting stored here inside the accumulator, and you can see that 5 operand is actually the part of the instruction. If this is the case, then this kind of instruction falls under the category of immediate addressing mode. And the next is called as register addressing mode. So, register addressing mode, all the operands will be specified only in registers here. So, we will be directly specifying all the operands or memories inside the register. So, I have given an example here, MOV A comma B, that means B, the value of B will be moving to accumulator value called as A here. Okay. So, for in this specific instance, I have a value called as 10, which is getting stored in B here, B register. So, I want to move this value 10 to A. So, operand is moving from one register to other register. This kind of mode is called as register addressing mode. You can see here that operand is getting moved from B to A here. Okay. So, this kind of addressing modes is called as register addressing mode. And the third one is called as register indirect addressing mode. So, what happens here is we will actually specify the memory address of an operand, and that operand memory address is called as effective address, because the address where the operand is getting stored is considered as an effective address here. So, you can see here that I have given an example that value of address of 2600. I want to move the value which is located in address 2600 to the register called as B. And in this instance, in address 2600, we have a value called as 150. So, this 150 has to be moved to B here. Okay. I specify the operand address in the instruction. So, if this is the case, it is called as register indirect addressing mode. You can see here that 150 is getting moved to B here. So, this is called as register indirect addressing mode. So, the operand address has to be specified in the instruction, and it has to be moved to the register. And now, what is meant by direct addressing mode? So, instructions which specify the memory address where the operand is stored is called as direct addressing mode. In this case, I am using instruction called as LDA. LDA is called as load inside accumulator. That means the address, the value in the address called as 2500 will be moved to the accumulator called as A here. Now, it actually loads the operand in address 2500 to accumulator. So, you can see here that 2500 is having a value called as 100. And after the execution of this instruction, this 100 will be moved to A here. So, I am actually visually depicting here. It is an illustration that how this instruction is getting executed. It is a simple demonstration. And now, you can also say that the another instruction called as STA. STA 2500 is also called as direct addressing mode. This actually stores the operand in accumulator to address called as 2500. In this case, in accumulator I have a value called as 200. So after the execution of this STA instruction, store instruction, what will happen is the value 2200 will be moved from A to 2500 memory location. Now you can see here. So this is getting moved over here. So this kind of instructions we specify in assembly language or falls under the category of direct addressing mode. Now the next is called as indirect addressing mode. So what is indirect addressing mode? When you specify the instruction, you will have two addresses. One is the effective address, another is called the ordinary address. This ordinary address holds the effective address here. So effective address actually holds the operand here. So in this case, we can see here B is a register, and the ordinary address here is called as 2500. So this 2500 is going to hold the effective address, and effective address is going to hold the value. So we can see the illustration now. So 2500 is holding the effective address called as 3200, and this 3200 holds a value called as 40. Now what happens is I want to move this value 40 to the register called as B here. So this is called as indirect addressing mode, because instead of using one address I am using actually two address here. Okay, one is ordinary address and another is called as an effective address. So using one address I am trying to access the value of another address. So this kind of mechanism is called as indirect addressing mode. You can see here the visual representation, the value of 3500 to value of 40 will be moved from 3200 to register called as B here at the end of this execution. So that's what it goes here. Okay, clear? Now the next is implied addressing mode. So what is implied addressing mode? When we talk about this implied addressing mode, the other name for implied addressing mode is also called as inherent addressing mode. In this addressing mode, we won't specify the operands here, no registers, no operands, no memory locations, nothing will be specified. Only an instruction will be taking place in this instruction, in this addressing mode. So what happens here? That means the operands will be taken implicitly. Automatically the operand will be taken by the instruction itself. We don't specify it. So I will just give you an example here. A CMA is called as complement accumulator. So what is meant by complement accumulator? Let's imagine that an accumulator is having a set of values 10, 11, 00, 11. So I make an 8-bit representation here. So before the execution of the CMA instruction, what happens is, this is the value which is located in accumulator. Now after this, after the execution of this instruction, so this values will get complemented. That means 1 will get converted to 0 and 0 will get converted to 1, and you can see here the visual representation here. So after execution of this instruction, completely the values inside accumulator will get inversed. So that is called as implied addressing mode. So I will give you two more examples for this, and this is after execution. Now another important thing is called as set carry, STC, set carry. That means you have learned about the status flag. In status flag there is a separate flag called as carry flag. So what happens is, when you use this command called a set carry, carry flag will be set to 1. So initially carry flag will be 0. So after the execution of this instruction, carry flag will be set to 1 here. Now the next is called as complement carry. So what is meant by complement carry? Complement carry means if the carry is actually possessing the value called as 1, it will be converted to 0, or if it is having 0, then it will be converted to 1. So vice versa it will be going. So that's called as complement carry. So this instruction only applies for the carry flag. Now in this case, you can see here I have a carry flag, I have a value called as 1. Now after executing this instruction complement carry, then it will be converted to 0. So, this is the nature of implied addressing mode. So, implied addressing mode, in short, we do not have any operands there, we do not have any registers there, but the operands and registers will automatically taken by the instruction implicitly. So, that is about implied addressing mode. The next is called as relative addressing mode. When the notion of relative addressing mode comes to picture, we always take the program counter into account. That means the program counter, you know that program counter will be having an address of the next executing instruction. Okay. So, what we are going to do here is we will take an effective address and we will compute an effective address by adding an offset value to the program counter. Normally, an instruction will be having only a value called as offset value here, and we try to add this program counter address with instruction offset value. Finally, we will take a value called as effective address. The effective address is nothing but where the operand address is called as effective address. This offset can also be called as displacement. So, you can see here that PC represents a program counter, and I have given a sequence of address and its values. So, spanning the left side, you can see the address 2004, 2005, 6 and 7 are called as addresses, and 4E, 20, 3A, 2D are called as the respective values in the appropriate locations. Now, let us assume that we have a program counter value called as 2005. So, 2005 is called as the next executing instruction address, and we will assume that offset is having a value called as 02. So, what happens here is this program counter value will be ordered with an offset value, and finally 2005 plus 2 will produce a result called as 2007, and that 2007 is called as an effective address. So, since in these locations we have 2007, but it should be 2007 here, a small mistake here because it should be pointing to 2007. So, a wrong highlight has been given here, 2007, it will be representing the value called as 2D here. Okay. Now, the next is called as addressing mode, the index addressing mode. So, what is meant by index addressing mode? In this case, the index register will be index value will be added with the base value here. Okay. So, the base remains actually the same, the index keeps on changing. So, we will never change the base value, but we will be keep on changing the index value, and when this index and base values gets added over there, it always represents the effective address, and this kind of addressing mode is called as index addressing mode. Now, in this case, when we talk about index register here, let us assume that the base value is actually 2004, and the index register will have a value called as 000. Okay. So, what happens is we will add the base value with the index register value. So, when we add the base value with the index register value, 2004 plus 00 will be resulting in 2004 itself. So, now this will be pointing to a value called as 2004. It will be pointing to 4E here. Now, suppose we actually increase the index value. Now, index value is actually incremented to 1. Now, already base value we are not going to change the base value, 2004 plus 1 will be 2005. Now, it should point to the next location here. You can see here that visual representation has been given here, 2005, it points to 2005. Now, the next is we will again change the index value, we will be going for 002. So, 002 index value. Now, base value is 2004, 2004 plus 2 should go to 2006. Now, you can see here now it is going to 2006. So, this kind of addressing mechanism is called as index register addressing mode. So, the next is actually a base register addressing mode. The previous case, it is actually similar to the previous addressing mode called as index register addressing mode, but the only difference is in the previous case we will not touch the base, we will keep on changing the index. In this case, actually base address will be keeping on changing here, and the offset will be remaining same here. So, that is the only difference between base register addressing mode and index register addressing mode here. Okay. So, I have given you a visual representation here. So, in this case we make the offset. Offset is actually a stable here, we are not going to touch the offset, offset remains the same value. Now, you see the base value here, base value actually represents a value called as 2003. So, 2003 plus offset will be going to a value called as 2004. So, base register values keeps on changing here. Now, the next is, now the base value is actually 2004 here. So, when base value is 2004, we try to add the offset again. Now, it should move to the value called as 2005. It goes here. Now, again base value is now 2005. If we try to add the offset once again, it should go to the value called as 2006. So, this kind of mechanism is called as base register addressing mode. Okay, nothing fancy about it. Very simple logic, you can follow this. Okay, a simple understanding, you can just try to do it. Now, the last addressing mode is called as auto increment or auto decrement addressing mode. So, it is actually similar to register indirect addressing mode. Here the register is incremented or decremented before or after its value is getting executed. Okay. So, when we try to execute one instruction, automatically the register value will get incremented by itself. Okay. This kind of modes is called as auto increment or auto decrement mode. So, we will go for the visual representation here. So, I have an address location spanning from 2004 to 2007. So, after the first instruction get executed here, it actually points to 2004, it gets incremented. After the second instruction gets executed, now it actually moves to 2005. Now, after the second 2005 is actually getting executed, now it will be moving to 2006. So, for every subsequent instruction execution, it will be moving like this. So, this kind of mechanism is called as auto increment or decrement addressing mode. So, that is all about addressing mode. Any clarifications is required, you can just comment me in the chat box. So, I can get in touch with you with appropriate clarifications. So, thanks for watching the video. Have a good day. Thank you and Jai Hind.